Hi guys, what I'd like to talk to you guys about today is a continuation of Taylor series, and we're going to talk about general terms and manipulating the Taylor series today. Let's do a little bit of review. If I have this table here of f's, f primes, and I want the third degree Taylor polynomial for f about x equals 3, how do I do that? Well, the table here is already generated for me, so I don't need to generate a table. What I need to do is I want the third degree Taylor polynomial. So that's going to be p to the third degree, and that's going to be equal to, and I know the formula for the Taylor polynomial, that's f of c plus f prime at c, x minus c over 1 factorial plus f double prime at c, x minus c squared over 2 factorial plus f triple prime c, x minus c raised to the third power over 3 factorial. And I'll stop there because I just need the third degree, and right now I'm at the third degree. All right, now I'm going to substitute in. I know that my c is equal to what in this problem? Well, this says the third degree polynomial for f about x equals 3. So that means my c value is 3. And c is what you use to develop your polynomial for the Taylor series. So my c here is 3. So I'll put 3 here, 3 here, 3, 3, 3, 3, and 3. Now I need to substitute in all my derivatives right here. So let's go ahead and put those in. f3 is negative 4, f prime of 3 is 2, this one's 7, and this one's negative 5. So let me write the Taylor series polynomial for f. This will be negative 4 plus 2 times x minus 3 plus 7 times x minus 3 squared over 2 factorial minus 5 times x minus 3 to the third power over 3 factorial. And I'm done. Sometimes there's some simplification you can do with the coefficients, but not always. All right, my next question says write the fourth degree Taylor polynomial for g of x, but that's g of x is equal to f of x squared plus 3 about x equals 0. So what they're saying is everywhere there's an x, I'm going to put in x squared plus 3. All right, so it's a substitution in a sense. But something we need to know about Taylor polynomials, substitution is only allowed if the function shifts the same as the center shifts. That's the only time substitution is allowed. And what do we mean by that? It's kind of a soft definition for shift. So if I look at this problem right here, I went from x to x squared plus 3. And what that means, if I think about the shifts that I learned in Algebra 2, changing an x to plus 3 actually means a left shift of 3. Okay? I mean, not exactly, but kind of. It's a soft definition of shift. Okay? And what was my center up here? My center in this original f problem, okay, so just to make sure I understood here, the function went from x to f of x squared plus 3, so that was a shift left of 3. My center shifted from, the center in the original problem was 3, and now the center is 0. So now the center is 0. So that's a shift of what? X went from 3 to 0, so that's actually also a left shift of 3. So since both of these are left shifts of 3, the F shift is the same as the C shift, then substitution would be allowed. And what does that mean when I say substitution is allowed? That means I can write this new polynomial, polynomial 4, by just replacing every x with x squared plus 3. So this will be negative 4 plus 2 times x squared plus 3 minus 3 plus 7 times x squared plus 3 minus 3 quantity squared over 2 factorial minus 5 times x squared plus 3 minus 3 raised to the third power over 3 factorial. And I want to go to the fourth degree. So let me simplify this. I have P4 is equal to negative 4 plus 3 minus 3 is 0. So that's 2x squared plus 3 minus 3 here is 0. So that's 7x4 over 2 factorial. And over here, this will be minus 5x squared raised to the third power. That's a power to a power. So that'll be x to the 6 over 3 factorial. I only want to the fourth degree. So what that means is I need to actually eliminate this term. And so this is my answer right here. And it's actually very important on the AP test that if they ask you to find to the fourth degree, that you only give the answer to the fourth degree. If you give the answer to the sixth degree, then what you're saying is you don't know what fourth degree means. All right, so what did we learn here? We learned that if you have a function, you know it's Taylor series, okay? If you want to do a substitution, if you want to replace every x with something else, x squared plus 3, you're allowed to do that in the Taylor series, okay, if your F shift and your C shift are the same. Let's talk a little bit more about shifting. So, for example, if I had f of x is equal to sine x, so we're going to talk a little bit more about shift, some shift talk up here. All right, if I want to find f of x plus 3, which means I want to say what is sine x plus 3 equal to, all right, then am I allowed to substitute? Well, I'm allowed to substitute if the function shifts the same amount as the center shifts. And just to understand shifting here, this right here would be, I would call this a left shift of 3. If I had f of x squared plus 3, I would also call that a left shift of 3. All right. What if I had a function, let's say f of x is equal to e raised to the x plus 4? What if I wanted to get f of x minus 5? Okay, so basically what I'm doing is I'm saying that's equal to e. And everywhere there's an x, I'm going to replace an x minus 5. All right, which is e to the x minus 1. All right, so I'm allowed to substitute x minus 5 into my Taylor series. I'm allowed to use substitution if the function shifts the same amount in the same direction as the center shifts. All right, and right now I'm just looking at shifts. So what would this shift mean? This would be a right shift of 5. Okay. What if I had something like this, f4x minus 5? That is also a right shift of 5. That would also be considered a right shift of 5. All right, let's look at this problem here. I want to find a Taylor series for f of x equal to e5 of x centered at c equals 2. Give the first 4 non-zero terms. Okay, something that we don't quite know yet, but I'll just tell you right here, is that the Maclaurin series, that means center is equal to 0, for e to the x is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x4 over 4 factorial. And you can see the pattern here. All right. And if I know the Maclaurin series, remember this would be my f of x, so to speak. And my center here would be equal to 0. All right. And I want to change it to e to the 5x. So I want to know what e to the 5x. Okay. It looks like a substitution problem. My f of x is changing to f of 5x. So x is going to 5x. What's the shift there? That's actually a 0 shift. Okay, it's not shifting left or right. What about this center? Now I want to get e to the 5x centered at 2. So c is going to go from 0 to 2. What kind of shift would that be for the c? That will be a right shift of 2. Okay? So I'm allowed to do substitution in the Taylor series. Okay? I can just change every x to 5x if the function shifts the same amount and the same direction as the center shift. And you can see here, the function shift here is 0, and the center shift here is a right shift of 2. Since they don't shift the same amount in the same direction, I'm not allowed to use substitution here. All right, so let's do this problem the long way. The way you would do this problem is you know that f of x is equal to e to the 5x. You need to get a table for all of the f primes. So let's start by first taking the derivative. That's going to be 5e to the 5x. The second derivative will be 25e to the 5x. The third derivative will be 5 times 25, which was 125e to the 5x. And I want the first 4 non-zero terms. I don't know if any of my terms will go to 0, but let's go to the fourth derivative just in case. So the fourth derivative will be, that'll be 625e to the 5x. All right, so now I want a table with all my c's equal to 2. So I'm going to substitute c into each of these x's. So f of 2 is equal to e 5 times 2, which is e to the 10. F prime of 2 is equal to 5e to the 10. F double prime of 2 is equal to 25e to the 10. F triple prime at 2 is equal to 125e to the 10. And finally, the fourth derivative at 2 will be 625e to the 10. All right, and I kind of see a pattern here, right? You just keep on multiplying by 5 and then 5 and then 5. So this would be 5e to the 10. This will be 5 squared e to the 10. This is 5 to the cube e to the 10. 5 to the fourth e to the 10. I see kind of that pattern. All right, so let's go ahead and write my Taylor series. My Taylor series is going to be, this is, I want the first 4 non-zero terms. So let me just write e to the 5x is approximately equal to, now it's not going to be equal, so be careful. Don't say it's equal when it's not equal. It's approximately equal to f at c, so it's going to be f at 2 plus f prime at 2, x minus 2 to the first power over 1 factorial plus f double prime at 2, x minus 2 squared over 2 factorial plus f triple prime of 2, x minus 2 to the cubed over 3 factorial, and so on. Since I put dots here, I actually could put equal signs here. Okay, if I didn't put the dots, then I can't put the equal signs. Let me go ahead and substitute in. So what I get for f of 2 is e to the 10. F prime of 2 is 5e to the 10. F double prime of 2 is 25e to the 10. F triple prime is 125e to the 10. All right, so what is this answer going to be? E to the 5x is equal to e to the 10 plus 5e to the 10 times x minus 2 over 1. I don't have to put that over 1. Plus 25e to the 10 x minus 2 squared over 2 factorial plus 125e to the 10 x minus 2 raised to the third power over 3 factorial plus, and let's see, did I get what I wanted? I wanted first 4 non-zero terms. 1, 2, 3, 4. There are 4 non-zero terms here, so I'm good. If I want the general term also, okay, what that means is to write a formula for this problem here. Write a formula. So the formula will be dot, 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 plus, okay? And the formula will be this right here. Remember, it's 5 raised to the n, if that makes sense, because this was n equals 1, this was n equals 0, this was n equals 2, n equals 3, n equals 4, right? The n is this, this power here. So this will be 5 raised to the nth power, this was always your n, times e to the 10, x minus 2 raised to the nth power, divided by n factorial, plus, don't forget to put dot, dot, dot. And there is my first non-zero terms plus my general term, okay? Now we derived the formula for sine x in the past, so you can look at the previous video to find it, all right? But what is sine x? Sine x is equal to, and I'll put it right here, it's x minus x cubed over 3 factorial plus x5 over 5 factorial minus x7 over 7 factorial plus dot, 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 plus some general term plus dot, dot, dot. And looking at this, I can see that my signs are going to alternate. So right here, I'm just going to say negative 1 raised to the n. And I can also see that I have odd powers up here. This will always be an odd power. So I'm going to call this x to the 2n plus 1 divided by, and I can see the factorial at the bottom is the same as the factorial as the number here, the exponent here at the top. So this will be on the bottom 2n plus 1 factorial. Okay, and sine this will be true for sine x from negative infinity to infinity. This is the radius of convergence of sine x, a unit which we skipped for the 2020 AP exam. All right, so let's check to see if this works. All right, so if n is equal to 0, then this would be negative 1 raised to the 0 power times x to the 1 over, this would be 2 times 0, which would be 1 factorial. All right, so this will give me x, and that's actually what I get here for the first term, x. All right, what if n is equal to 1? I would get negative 1 to the first power, which is actually negative 1, times x to the third power over, and if 2n plus 1 is going to be 3 factorial, and that actually does look the same as this negative x cubed over 3 factorial. And so we can go on, but this is going to check out starting at n equals 0. And n can start at 0, it can start at 1, it can start at 2, okay, as long as it increments and it makes sense, all right? Now, if we know the Taylor series for sine x, how do we get the Taylor series for cosine x? Well, definitely one way to do it is actually making a table for cosine x, right? So if we made a table for cosine x, what would it look like? We would say f of x is equal to cosine x. So I'm going to develop a table for cosine x here. F prime of x is equal to sine x, negative sine x. F double prime of x is equal to negative cosine x. F triple prime of x is equal to sine x. The fourth derivative of x will be equal to cosine x. And then I want to do a Maclaurin series. All right, so just make sure this is a Maclaurin series. This is the center at 0. And so if I said the center was 0 here, then f of 0 will be equal to cosine of 0, which is 1. F prime of x, or f prime of 0, will be equal to negative sine of 0, which is 0. F double prime of 0 will be equal to negative cosine of 0, which is negative 1. F triple prime of 0 will be 0. The fourth derivative at 0 will be 1. Okay, remember I plugged that into my Taylor series formula. Okay, so that means cosine of x is approximately equal to, or I can put dot, 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 so I'll say equal to f at 0 plus f prime at 0, x minus 0, you can leave out the x minus 0, over 1 factorial plus f double prime at 0, x squared over 2 factorial, plus f triple prime at 0, x cubed over 3 factorial plus the fourth derivative at 0, x4 over 4 factorial plus dot dot dot. And if I substitute this in, what I get is f of 0 is 1 plus, well, f prime of 0 is actually 0, so this will go to 0. F triple prime will also go to 0. So this will become negative 1 x squared over 2 factorial plus positive 1 x4 over 4 factorial. And I can see kind of the pattern that's emerging here. I know this is the pattern for sine. This is going to be the pattern for cosine. And you can see that I can propose that I think this will be negative x6 to the 6 factorial next plus x8 to the 8 factorial next, and so on. And is this true? Well, let's think about this. One thing you can do, if you know that sine x is equal to this Taylor series here, is multiply both sides by the same thing, or divide both sides by the same thing, or maybe take the derivative of both sides. Okay, if I took the derivative of sine x, what is that? The derivative of sine x is cosine x. What's the derivative of x? 1. What's the derivative? Remember, this is a constant. So what's the derivative of x cubed? That's 3x squared over 3 times 2 factorial plus, what's the derivative of x to the 5th? That's 5x to the 4th over 5 times 4 factorial. What's the derivative of x to the 7? 7x6 over 7 times 6 factorial plus dot 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 plus. And you can even do it to this term right here. This right here is actually a constant. This alternating thing is still alternating for cosine, right? So let me just put in negative 1n, okay? The derivative of x to the 2n is going to be 2n plus 1 times x raised to the 2n plus 1 minus 1 divided by, and the denominator is just a constant, so this will be 2n plus 1 times, well, that's just going to be 2n factorial, right? And look at what cancels out here. The 2n plus 1s will cancel out. This will become 0 here. So remember, this is plus dot dot dot. So I can write that cosine of x is equal to 1 minus x squared over 2 factorial plus x4 over 4 factorial minus x6 over 6 factorial. And is that the same as what I thought I would get here? Yes, it is. Plus dot 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 plus negative 1 to the n times x to the 2n over the quantity 2n factorial plus dot dot dot. And this is for cosine. For the radius of convergence will be negative infinity to infinity for cosine. All right, so I've developed the formula for cosine here. You need to memorize the formula for sine x. You need to memorize the formula for cosine x, the Taylor series formula, and also for e to the x. Those are things that people just know. The general formula also is something that you should memorize. Let me check to see if this general formula is right, because this negative 1, sometimes it should be negative 1 to the n plus 1, and sometimes it should be negative 1 to the n. So let me check to make sure this is right. If I put in, let me try n equals 0. If I put in n equals 0, what I'll get is negative 1 to the 0 times x to the 0 over 0 factorial. But 0 factorial is actually 1. So what I get here is actually just 1. All right? That's going to match up with this first term here, which is 1. If I put in n equals 1, so that would turn into negative 1 raised to the first power x raised to the 2 times 1 over 2 factorial. And is that the same thing as this second term here, x squared over 2 factorial? Actually, negative x squared over 2 factorial. Yes, it is. And I can check more terms, but it turns out this is the correct general term for cosine of x. What we're going to do next is look at different ways that we can manipulate in order to find different Taylor series without having to do the table all over again. Okay, so the first one we're going to look at is substitution, which we talked a little bit about substitution already. Then we're going to talk about multiplying or dividing both sides by the same thing. Then we'll talk about how we can add or subtract. And in between all of that, we'll talk about how we can take the derivative of both sides, which we did already with the cosine and sine, or we can integrate both sides, and that is feasible also for Taylor series. So let's look at the first problem here. If I take every x for sine x and I put in x squared, can I do a substitution? All right, so let's see what I'm saying here. If I know that sine x is equal to, all right, and what do I know that sine x is equal to? It's x minus x to the third power over 3 factorial plus x to the fifth power over 5 factorial minus x to the seventh power over 7 factorial, dot, dot, dot. And I want to find sine of x squared. Could I just substitute the x squared for the x? Is that allowed? Well, let's think about that. If I go for the function shift, okay, what I'm doing is changing the x to an x squared. What kind of a shift is that? That's actually a zero shift. Remember, we're defining it very softly. All right, what about the center shift? It's got to be the same in order to do substitution. All right, well, up here, this sine x here, this was the Maclaurin series that we memorized. So this right here is going to be a center of 0. All right, and then when I find this sine x squared, am I also doing a Maclaurin series? Yes, it says find the Maclaurin series here. So the center here will also be 0. So what kind of shift will the center be? It'll be a 0 shift, okay? Since these are the same, okay, the F shift is the same as the C shift, then I'm allowed to do substitution here. And what does that mean? That means for the Taylor series, anytime I see an X, I can just substitute it with X squared, okay? Make sure your math is right here. This is a substitution. It's not multiplying by X squared, okay? It's substituting. So there's an X here, I change that to an X squared. There's an X here, I change that to an x squared, but there's also a 3 on the outside. There's an x here, I change that to x squared, but there's also a 5 on the outside. And there's an x here, and I change that to x squared. Okay, I also want to know the general term. So for sine x, I know my general term was -1 to the n, and it was, these are odd numbers, so this is going to be x to the 2n plus 1 over 2n plus 1 factorial plus dot, dot, dot. Okay, so you can do the same thing to the general term that you did to the other terms. So let's think about this. It's still an alternating series, so it's easy to just leave this -1 to the n here. All right, now everywhere there's an x, I'm going to put in x squared. So this becomes x squared raised to the 2n plus 1 over the quantity 2n plus 1 factorial plus dot, dot, dot. And I also want to say that this general term here is not unique. So there are also other possible general terms that are still correct. You just need to check it to make sure it works for the Taylor series that you're doing. I can simplify this. Sine of x squared is equal to x squared minus, this is a power to a power, so that's x6 over 3 factorial plus x10 over 5 factorial minus x to the 14 over 7 factorial plus dot, 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 plus -1 raised to the nth power times x, and this is power to a power, so that's going to be 4n plus 2 all over the quantity 2n plus 1 factorial plus dot, dot, dot. And remember, this 2n plus 1 factorial was a constant, and these denominators never changed. All right, so that's why the denominator here for the general term did not change either. All right, what if I asked you to use this answer in A to find a Maclaurin series for f prime of x? So what's f of x? F of x is sine x squared. So this is sine x squared here. What I want to know is the derivative of sine x squared. If I wanted to take the derivative of both sides. Okay? Taylor series allows you to do that. You can take the derivative of this term, and that will be equal to the derivative of the sum of all of these terms here. So let me put in a little sum symbol here. Okay? Not always, but in this situation, you can actually take the derivative of this, right? The derivative of sine x squared, the derivative of sine u is cosine u du dx, right? So this derivative on the left side is 2x cosine x squared. And we know that is equal to, and the derivative of each of these terms. So that's 2x minus 6x to the 5th over 3 factorial plus 10x to the 9 over 5 factorial minus 14x to the 13 over 7 factorial plus dot 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 plus, okay, the alternating part doesn't change, so I'll leave it as negative 1 over n. The denominator didn't change either, right? As I went through, they're all constants, okay? And when you take the derivative of something, right, these are like scalars, so they just kind of pull out and come back in. So this 2n plus 1 factorial was like that. That was just like a scalar, and that stayed the same, okay? Now, I also have to take the derivative of this x to the 4n plus 2. So that would be 4n plus 2 times x raised to the 4n plus 2 minus 1. But 2 minus 1 is actually just 1. All right? I'll lengthen that bar plus dot dot dot, and this is my answer to the derivative of f of x. You're allowed to manipulate the table series by taking the derivative of both sides. All right. Another way you're allowed to manipulate the Taylor series is actually, if I know cosine of x, I can just multiply cosine of x by x. But remember, you got to do your algebra correctly. You got to use real algebra, not the fake stuff, all right? So let's look at what f of x, x to the cosine x will be, okay? If I put this into a table, it would actually be pretty difficult to do, okay? Let me talk to you about why, okay? The table is a long way to do things, and sometimes we just have to do the long way, right? The long way is you need all the derivatives of f, and you stick that into the Taylor series formula. But look what happens if I take the derivative of x cosine x. You have to use what? The product rule, right? And then if I took the second derivative of that, okay, look how terrible it's going to turn out. Okay, I'll have to use the product rule again, all right? And this will just escalate, okay, as I move down. So what I'm going to say is, hey, maybe there's a trick I can use to avoid the product rule here. And sometimes you can't avoid it. But if it's one where it gets pretty complicated, then possibly there's a trick. All right, so let's look at this trick. All right, what I know is cosine x is equal to 1 minus x squared over 2 factorial plus x4 over 4 factorial minus x to the 6 over 6 factorial plus dot 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 plus the general term is negative 1 to the n, x raised to the 2n, all these exponents are even, so that's where I get the 2n, over 2n factorial plus dot dot dot. That's cosine of x. Now what I want though is x times cosine of x. So on the left side I can multiply this by x. So on the left side I can multiply this by x and I'll get x cosine of x. On the right side I can also multiply the right side by x, but be careful. You have to multiply the entire right side by x. It would be incorrect to just multiply this first term by x, all right? Because that's not what cosine x is. You're multiplying x times the whole cosine of x. So I have to multiply by the whole cosine of x here and distribute. So what I get is x to the cosine of x. X times cosine of x is equal to, I'm going to distribute this x. So x minus x cubed over 2 factorial, x5 over 4 factorial minus x7 over 6 factorial plus dot 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 plus. Notice that the scalars here never got multiplied. All I did was multiply the numerators by x. So I'm going to do the same thing to the general term. It's still an alternating series, so negative 1 raised to the n. This x will be x times x to the 2n, so x times x to the 2n. If I multiply factors with the same base, then I add the exponents together. So this will become x raised to the 2n plus 1 over, the denominator never changed throughout each term, so this denominator will stay 2n factorial, 2n quantity factorial plus dot dot dot. And that is my answer for x cosine x. And I can do it the long way if I just want to be a masochist and check myself. All right. Then it says, use my answer in A to find the Maclaurin series for the integral of ft dt. Give the first 4 non-zero terms and the general term. All right. So this is really saying you can take the integral of both sides. All right. What is my ft dt? Well, my ft is just my f of x. All right, with t's in there instead of x's. All right. So let me just rewrite this with t's. All right. So ft will be equal to t cosine of t is equal to t minus t cubed over 2 factorial plus t to the 5th over 4 factorial minus t to the 7th over 6 factorial plus dot 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 plus negative 1 raised to the n. Remember, the x turns to t's, the n's are still there. T 2n plus 1 over 2n quantity factorial plus dot dot dot. Okay, what I want to do is take the integral of f to the t. So I'm going to take the integral of this side from 0 to x dt. And I can do that if I also take the integral of this from 0 to x dt. All right, this whole thing right here. All right, so how do I do that? What I do is I have to take the integral of basically just every term, right? It's a buy one, get infinity free. Okay, what a deal. All right, so let's look at what this integral is. This integral of ft dt will be equal to, and I'm going from 0 to x, it will be equal to, let's take the antiderivative of each term. So t squared over 2 minus t fourth over 2 factorial times 4, right? This 2 factorial is just carried down. This is a scalar here. And this 4 is from taking the antiderivative using the power rule, all right? And this will be plus t6 over 4 factorial times 6 minus t8 over 6 factorial times 8 plus dot 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 plus, and let's see what I'm doing. All right, all the alternating signs stay the same, so let me carry down this negative 1 raised to the n power. All right, what did I do with the t's? I added 1 to each of the t's, so 2n plus 1 is going to be now t2n plus 2. All right, I divide that by, this denominator stayed every time, the 2 factorial, 4 factorial, 6 factorial. So this 2n factorial will stay. But I also multiplied by this exponent. So if this exponent was 6, I multiplied by a 6. If this exponent was 4, I multiplied by a 4. So if this exponent is 2n plus 2, then I'm going to need to multiply by 2n plus 2. And then don't forget plus dot dot dot. Then I need to do the win bar, and that goes from 0 to x. Okay, so first I'm going to substitute in x. Everywhere there's a t. I don't substitute for the n. Okay, I'm substituting x everywhere there's a t. All right, so this will be x raised to the 2n plus 2 over the quantity 2n plus 2n factorial times 2n plus 2 plus dot dot dot, and I'm going to subtract, plug in the 0, okay? So I'm going to subtract, plug in the 0, but do you see? When I plug in 0 for t, I'll get 0 minus 0 plus 0, okay? So whatever I get here, it'll be 0 minus 0 plus 0 minus dot dot dot, okay? So the nice thing is most of the time, or all of the time I think, anytime they ask you to do an integral, they'll put a 0 on the bottom so that this problem is manageable. All right, so now we have our answer. The end here is just 0, so this you don't have to think about. And so our answer here for the integral of ft dt from 0 to x is right there. Lastly, another manipulation we can do is we can add terms together. All right, so e to the x, what is e to the x? Let's think about this. We talked about what e to the x was before. Let's go ahead and derive e to the x, because I don't think we've done that. So if we have f of x is equal to e to the x, we'll know f prime of x is equal to the derivative of e to the x, which is e to the x. F double prime is equal to e to the x. F triple prime is equal to e to the x. This is interesting. So the fourth derivative will be e to the x. The fifth derivative will be e to the x. That's interesting. And if I wanted the Maclaurin series for e to the x, then my c would be 0. So this would be e to the 0, which is 1. F prime would be e to the 0, which is 1. F double prime would be e to the 0, which is 1, and so on. Let's go ahead and write my Maclaurin series. All right, the Maclaurin series for e to the x will be equal to f at 0 plus f prime at 0 times x over 1 factorial plus f double prime of 0 times x squared over 2 factorial plus f triple prime of 0 x cubed over 3 factorial plus f fourth at 0 x to the 4th over 4 factorial plus dot 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 plus, and we'll think about what this is. Let's go ahead and substitute in right now. So f0 is going to be 1, f prime 0 is going to be 1. All of these turn out to be 1, right? So what we get for e to the x, which is one of the easiest to memorize, but hard because we get it confused with cosine x and sine x. E to the x is 1 plus x squared over 2 factorial plus x third over 3 factorial plus x4 over 4 factorial plus dot 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 plus. And if you notice, we have no alternating terms here, so we don't need a negative 1 power. This is just goes from x to the nth power, right? So this will be x to the nth over, and whatever the exponent is, the denominator will be the same factorial plus dot dot dot. So e to the x is one of the easiest to memorize. What is e to the x plus e to the negative x? Well, let's think about that. Well, if I know this is e to the x, what would e to the negative x be? Well, isn't that just everywhere there's an x, I'm going to substitute negative x? Well, is that allowed? Is this substitution allowed? Well, it's allowed if the function shifts the same as the center shift, the same amount in the same direction. Well, if I go from x to negative x, that's actually a 0 shift, okay? The Maclaurin series here, this is Maclaurin series, says that the center is 0. The e to the negative x I want is also a Maclaurin series, all right? This is also a Maclaurin series, so the center is also 0. So I'm going from a center of 0 to a center of 0, so that's also a 0 shift. So the f shift is 0, the c shift is 0, so therefore I am allowed to use substitution here. So I'm going to substitute x with negative x. Let me look at my e to the x here, and everywhere I see an x, I'm going to put in negative x. So that'll be 1 plus negative x. So 1 minus x plus the x changes to a negative x. It's a substitution. It's not changing the sign, okay? So make sure we understand. Everywhere there's an x, we're substituting the quantity negative x. And this will be negative x raised to the 4th power over 4 factorial plus dot 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 plus negative x raised to the n over n factorial plus dot dot dot. All right, so the question is, what is e to the negative x? That's going to be 1 minus x plus negative x quantity squared will give me x squared over 2 factorial. Negative x to the 3rd power is going to give me negative x to the 3rd over 3 factorial. Negative x to the 4th power is going to give me positive x4 over 4 factorial. And I can see the pattern that's happening here. This will be plus dot 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 plus negative x raised to the nth power. Okay, this is kind of difficult to see, but this is really the same thing as negative 1 times x raised to the nth power. All right, and the n will distribute here. So this will be negative 1 to the nth power times x to the nth power. So this will be negative 1 to the nth power times x to the nth power over n factorial plus dot dot dot. All right, so I have e to the negative x. I also have e to the x. So, all right, what happens when I add the e to the x? When I add the e to the x with the e to the negative x. Let me try to add them together. 1 plus 1 is going to give me 2, right? So this is going to be e to the x plus e to the negative x. Negative x plus x is going to give me 0. These two added together will give me 2 times x squared over 2 factorial, which is 2. All right. These terms here will be 0. These terms here will be 2 times x to the 4th over 4 factorial plus dot 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 plus, and really all that's happening here, I can recopy this 2 factorial. All that's happening here is that I'm multiplying all the even ones by 2, and all the odd ones are going to wipe out, right? So if it's odd, it's going to wipe out, and you can see all of the signs here are going to turn positive, all right? So I can see the pattern here. This will be plus 2 times x to the, they're all going to be even numbers, so it's 2n over 2n factorial plus dot dot dot. So if this is what e to the x plus e to the negative x is that what I'm trying to find? No, I'm trying to find this summation divided by 2. So what I can do is divide both sides by 2. So if I divide both sides by 2, I have to actually come in here and divide every term by 2. So what I can find is e to the x plus e to the negative x divided by 2 is equal to 1 plus x squared over 2 factorial plus x4 over 4 factorial plus dot 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 plus x to the 2n over quantity 2n factorial plus dot dot dot. And this is the example of how you can add Taylor series together also.